In this video we are going to take a look at octal number system. Octal number system, and then we are going to see how to convert an octal number to binary and also to decimal. Okay, first let's see how to convert it into decimal, then we can see how to convert it into binary at last. Okay, so first of all, let's say we have a number 296 and if it's base 8, and this one is actually like, let's say we want to convert this one into decimal. This question itself is wrong because for an octal number it cannot have anything more than 7. It cannot even have the 8, so it should be less than like 7 or less than that. So if I put 1 to 7 any number, that will be right. So I have to change this one into an octal number. Okay, yeah, same thing for the decimal. The maximum is 9. Whichever number we have for the base is 1 less than that. So for the octal the maximum number is 7, for the decimal the maximum number is 9, and if it's hexadecimal the maximum number is it's a 16, so 15 is the maximum number. So we will see that later, but for this one you have to just know it goes up to 7 only. So 216 is an octal number, and we want to convert this one into decimal, and we want to know the weight of each location. So the first number is 8 power 0th location, and then the second number is 8 power 1, and then the third number is 8 power 2. So if we want to convert, we just try to multiply and add them. So the 6 is in the 8 power 0 location, so 8 power 0 times 6 plus, and then 8 power 1 times 1 plus 8 power 2 times 2, and we know 8 power 0 is 1, 1 times 6, 6, 8 power 1 is 8, 8 times 1, 8, and then 8 power 2 is 64, 4 times 2, which is 128, and then 128 plus 8 is 136 plus 6, 142. So the conversion of this this octal number to decimal is 142. Okay, so this is one example. Let's look at one more example. I put it in the new page because we are going to use this number later for we are going to see how to convert to octal to binary. So in this one we will use this again. Let's look at the second example. So let's say we have something like 7.254 and the base is given by octal. We want to convert this one into decimal. And first of all, is this right? This is right because all the numbers are below 8. 7.254, so this is an octal number, and then we want to convert this into decimal, and we have to know the weight of each location. So before the decimal point, whichever the number comes first, which carries 8 power 0's location, start from here, it increases, like from right to left it increases, and from left to right it decreases. So here this one is 8 power 0, then after the decimal point it comes like 8 power minus 1, 8 power minus 2, and then 8 power minus 3. Okay, and then if we put them, this is 7 times 8 power 0 plus the 2 is in the 8 power minus 1 location, so 2 times 8 power minus 1, or you can say 2 over 8 as well. 2 over 8. Okay, and then the next one is, okay, this should be plus here. Okay, so the next one is 5 over 8 power minus 2, which we can write as 5 over 8 power 2, which is 64. And then the third one is 4 times 8 power minus 3, which we can write as 4 over 512 as well. And if you calculate this one, 7 times 8 power 0, which is 7, because 8 power 0 is 1, so we get the 7 again, and then if you calculate and add them, you get 3,359,375. Okay, so the conversion of this octal number to decimal is 7.3359375. okay, that's how we convert from an octal to binary, octal to decimal. Let's say if we want to convert to octal to binary, how can we do that? We know how to convert from octal to decimal. Octal to decimal, we just saw the method. So if we have base 10, we know how to convert it into actually base 8, we know how to convert it into base 10. Okay, and from converting to base 10 to base 2 is easy. So it's like you convert the octal to decimal first, then decimal to binary after that. There's a shortcut to do that, but we will see that later. For a beginner, like initially when you're learning number system, this is a good method. Like you first convert the octal to decimal, then decimal to binary. So let's look at this example right here. So here we saw how to we have seen that how to convert this one from octal to decimal. Now we are going to convert this decimal to binary. Now in order to convert a decimal to binary, what we have to do is we have to keep on dividing by the number by 2 until we get 0. So let's go ahead and do that. Okay, so here we have 142, and if I divide by 2, that is 71, and there's no remainder, so remainder is 0. Okay, then 71 divided by 2, which is 35, and there's a remainder of 1, and then 35 divided by 2, which is 17, and there's a remainder of 1, and then 17 divided by 2, which is 8, and then there's a remainder of 1, and then 8 divided by 2, and there's a 4, and then remainder is 0, and then 4 divided by 2, which is 2, and then the remainder is 0, and then 2 divided by 2, which is 1, and there's a remainder of 0, and then 1 divided by 2, which is 0, and the remainder is 1. So once we get 0, we stop right there, and then we read from bottom to top. So that the conversion of this the equivalent of this one in binary is 10001110, and that's our final answer. And that's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my